Okay, well, I had a Zoom meeting and then for some reason I didn't hit record, but that's okay. We're going to go with it. So I'm going over today's assignment. One of them, the vocabulary you should be able to do. Use those notes I gave you, and you should be able to do that. Let me get rid of this dot. It's driving me nuts. Okay, so number one, it says to find a mole. A mole is essentially, no matter what it is, methane, oxygen, nitrogen, carbon dioxide, it doesn't matter. Okay, 1 mole is always 6.02 times 10 to 23 molecules of whatever it is. Okay, methane, oxygen, nitrogen, carbon dioxide, whatever it is, a mole, 1 mole is that. Okay, and everything has to go through moles. That's why we have to know what they are. So the main things we're going to be looking at is, okay, I'm going to put molecules over here. Okay, if we want to go from molecules to gram, so if we're going from molecules to gram, we got to first go through moles. If we're going from grams to molecules, we got to first go through moles. Now if we just go from moles to molecules, then we don't have to fool with all that. Okay. All right. So.
Check mark. Push out with 2 fingers. No, Mom.
Stop. I'm trying to figure out how to do a new slide.
There's no slides.
No slides. Okay.
Okay, click the
check mark. There we go. That'll work. All right. So, number 2, okay, so I'm doing number 2. It's asking me how many moles, so that's what I'm trying to figure out, how many moles, if I have 34 grams of carbon hydroxide. Okay, copper hydroxide. All right, so the first thing I got to do is figure out the molar mass for that 1 mole. So, 1 mole equals, let's see, copper, if I look it up on my periodic table, is 63.55. Okay, that's the copper. If I'm looking at oxygen, it's 16. But I have 2 of those because of the subscript here. This 2 right here means 2 times 2, 2 times 2. So that gives me 32. This is my oxygen. And then my hydrogen, I have 2, and it's 1. So that's 2. So if you add all this together, you get 97 grams of carbon hydroxide. Okay. Now, it's copper 2 hydroxide, actually. So, it's wanting to know how many moles. Well, I know the grams of 1 mole, okay? And I know I have 34 grams. So if I set up my dimensional analysis, I have 34 grams of CuOH2. Okay, and I know 1 mole is 97 grams of CuOH2. This cancels out, and then I just plug and chug it, and I get, what did I get? 0.35. 5 moles of CuOH2. So copper 2 hydroxide, if I start off with 34 grams of it, I actually have 0.35 moles of it, which makes sense because we know 1 mole is 97, so this should be less because I don't have 97 grams. All right, so I don't know what that did. I just wanted to see what it would do. All right. All right, so let's go back to number 3. Okay, now number 3 says how many present moles. So once again, we're looking for moles. Okay. And they give us the molecules, which is 2.45 times 10 to the 23rd molecules, of CH4. Okay, that's a 4. So I'm going from molecules to moles. So what I can do is put it in my dimensional analysis. All right, I know that they give me 2.45 times 10 to the 23rd, okay, and that's of CH4. And I know 1 mole of CH4 is always 6.02 times 10 to the 23rd molecules of CH4. Okay, 1 mole of this is always this. Okay, this is really important right here. 1 mole is always this, no matter what it is. All right, so if I plug and chug that in, this cancels out, this cancels out. So 2.45 divided by 6.2, I get 0.41 moles of CH4. Okay, it's just like what we've been doing the last 4 weeks. It's dimensional analysis. In order to figure out the moles, I figure out 1 mole of methane is 6.02 times 10 to the 23rd, and I plug it in and check it out. Remember, you don't have to do these lines like I do. All right, so let's go to the next one. And I don't expect you to get this right away. I really don't.
Red.
Number 4, they want me to know how many grams. Okay, so that's what we're looking for. They give me the molecules times 10 to the 24th of ammonia. Okay, well, I know I can't just go from grams to molecules, okay, because it's grams to moles to molecules, or it's molecules to moles to grams. Okay, so I'm wanting to find out grams. All right, and I know they give me the molecules. So the first thing I have to do is I have to figure out the molecular mass of ammonia. And if I do that, I know nitrogen, I just have 1, so that's 14. And I have hydrogen, that's 3 times 1, so that equals 17 grams per mole. All right, now I'm just going to draw my dimensionals. Okay, so I'm going to start off with 3.4 times 10 to the 24th NH3. Okay, I know that 1 mole of NH3, and sometimes I forget to put the E, because when you get into college, you'll just write MOL, is 6.02 times 10 to the 23 of ammonia. Remember, 1 mole is always 6.02 times 10 to the 23rd, no matter what it is. Okay, so that gets rid of this, and it still is moving with the 10, so that's actually now a 34. Okay, now I have moles. Okay, and I want to get to, remember, grams. So I can do it that way. I know that 17 grams of NH3 is 1 molecular, that's the molecular mass, of NH3. Okay, so this canceled this out, this canceled this out. So when I plug and chug it in, I get 96 grams of NH3. So if I start off with this, okay, and they want me to find out grams, remember, I've got to go from molecules, then to moles, then to grams, and so I had to first find the molecular mass, and then use my dimensional analysis to figure it out. And I get 96 grams. So essentially, I am doing the math part of this worksheet for you. So really all you got to do is the last two definitions. All right, so let's go back. And we're on number 5. Okay. It asks, how much does 4.2 moles of calcium nitrate weigh? So it's asking me the grams. Okay. Well, I know because if you draw that little thing that I was doing, okay, that's molecules, this is moles, okay. If I'm going from grams to moles, this is all I'm concerned with, all right. But in order to do that, I've got to figure out the molar mass for that, or the molecular mass. I like to say molar mass. So calcium is 40. I'll find that. That's the atomic mass of calcium. Nitrogen, now I have 2 of those. Okay, because here's a 2. Okay, go away. Okay, here's the 2. So I've got to make sure that I take this 2 and put it in there. So I have 2, and if I look on the periodic table, nitrogen is 14. And then my oxygen, 2 times 3 is 6, and that's 16. So if I add that all up, I get 164 grams is the molar mass. Okay. Now, oops, sorry guys. All right. Get rid of that. All right, so I'm going to set up my dimensional analysis. Okay. I have 4.2 moles of calcium nitrate. Okay, I know that 1 mole of calcium nitrate, okay, equals 164 grams of calcium nitrate. Now, right now, we're just working with one compound. We'll get into reactions later on. So, I'm going to, this cancels out. Okay, that cancels out. So, 4.2 times 164 gives me 689 grams of calcium nitrate. That's the answer. Okay, so this is the answer. And I'm doing dimensional analysis just like we've done the last 4 weeks before spring break. Okay, the last problem is asking for the molar mass. So number 6, the molar mass of magnesium oxide. Okay, so that's real simple. Magnesium is 24.3 on that's the atomic mass. And then oxygen is 16, so I'm left with 40.3 grams of magnesium oxide. That is the molecular mass or molar mass. We use molar mass when we're doing stoichiometry because we're talking about moles, okay, molar. Whereas atomic mass is not really what we want, okay? We want what's the mass of this as it pertains to molar. So answer 7 and 8 on your own. If you have any questions, email me. I am going to set up a Zoom time for Friday to go over any problems that you're having. Tomorrow, it should be the same stuff here that we did today, okay? And if I see that a lot of people are having problems, I'll get back on here, do a quick video, and send it to you. But the rest of the week, you're just going to be doing problems like this, okay? So refer to this, refer to the video. The other video, if you open up yesterday's assignment, there's a video, CK12. He will go through it and go over it too. Maybe he'll make more sense to you than I do. But if you have any questions, please email me.